Well, hello, geometry students. It's Mrs. Applegarth again. In this section, we are going to talk about corresponding parts of congruent triangles. So there's a little property. It is called CPCTC. It says corresponding parts, so the parts that match up of congruent triangles. So the parts that match for triangles that are congruent to each other. What that means for us is when you prove that triangles are congruent, all the parts in the triangles are congruent to each other. So we're going to use this fact to match up and declare parts that are corresponding. So let's see how that works. If we're given angle 1 congruent to angle 2, and you know I'm going to go draw on our shape. So 1 and 2 are congruent. Boop, boop. Angle 3 is congruent to angle 4. Boop, boop. We'll double rainbow them. We want to prove, and let's just outline it, B, C, E is congruent to D, C, E. So these two little triangles here. Our hint here, and this is a giant hint, is that we have to first prove the bigger triangles are congruent. So that is ABC. So this big guy here is congruent to ADC. So we have to prove that these two little triangles are congruent, or the big triangles are congruent, so we can get down to the little guys. So the first thing we put on our statement, boo, 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 is what we're given. So our angles are, actually let me dial this back real quick. So angle 1 congruent to angle 2 and angle 3 congruent to angle 4. That information was given. The hero of this proof is going to be the reflexive property. So the next piece we want is going to be CA congruent to CA. And so let's look at that. Boom, here. All right, so now CA congruent to CA, boom, reflexive all day. When one item is congruent to itself, that's going to be reflexive. So now we have a triangle ABC congruent to triangle ABC. And we need to determine what property we can use to declare that. And we have the options of, we learned this last week, side, 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 angle, and angle, angle, side. So out of these 4 choices, we have to look at what we have and see which one we're utilizing here. So we have an angle. We have this angle here. We have the side, and then we have another angle. And the side is in between the 2 angles. So it is going to be angle, side, angle. So the triangles are congruent. The big green guys are congruent by angle, side, angle. All right, so now we're going to hunt down. We did our hint, so we proved this. So now we're hunting down our final item, and that's to prove triangle BCE is congruent to triangle DCE. So the little guys. So let me show you. Which the little guys are. And I'm not going to erase what we've already proven congruent because that already gets to be congruent. So the little triangles are BCE and DCE. We have that this angle is congruent to this angle. CE, CE, and D, CE. Okay, so we're going to say that DC, boom, is congruent to BC because in the big triangles, they're corresponding parts. They match up in these big triangles. So if I've proven that the triangles are congruent, then these sides are the congruent matching sides. So DC is congruent to BC because corresponding parts, CP, are congruent, of congruent triangles are congruent. So it's a CPCTC. So those are parts that go together. The next thing we're going to prove is that CE is congruent to CE. And that's the hero. That's our reflexive property again. And then finally, we should have what we're trying to prove on the last line. Triangle BCE, this little guy in the blue, congruent to DCE. And let's count. We have this side, we have this angle, and we have this side. So that would be, out of the four, it would be side, angle, side. Awesome possum. After doing all these proofs, you guys are going to long for some algebra solving, some quadratic equations. Okay, so let's look at example 2. We are given that angle B is congruent to angle D, and that C bisects AE. So AE is this whole thing. C bisects it, and we will pop that in just a minute. We'll draw on it. Okay, so angle B and angle D and C bisects AE. That is always going to be given. This is your free points. You always know that the top one is going to be given. The next item says AC is congruent to EC. The reason it's congruent is because C bisects AE. What that technically is the definition of a bisector. So if C bisects AE, it creates two congruent or equal segments. All right, one of my favorites, angle 1 is congruent to angle 2. And we can say the kind of angles that those guys are, anytime it's a bow tie, you see the bow tie triangles where they're connected and it kind of looks like a little sassy bow tie man. That's going to be vertical angles. Oh my gosh, chapter 1 coming back at us. So now we're going to claim that triangle ABC is congruent to triangle EDC, and let's see the reasoning. It's going to be one of these four, and we have an angle, and then as I go around my triangle, we have another angle, and then we have a side that's not included. So that is angle, angle, side. So the triangles are congruent by angle, angle, side. And now last but not least, we want to prove angle A is congruent to angle E. And we're going to say because, so here's A and here's E. Those are corresponding parts of triangles that we've already proven are congruent. So we say angle A is congruent to angle E because corresponding parts of congruent triangles are congruent. CP, CTC. All right, you guys, I'm going to, it's that time. Go do the practice assignment. Make sure you check your answers before you turn it in, and have an amazing day.